Welcome everyone to the second Black Hole Initiative conference. We just ended another conference on gravitational wave astrophysics for 2.5 days. As a prelude to this conference, as you know, LIGO detected the number of black holes and many more to come. They haven't revealed any secrets about the data that is still being analyzed. But let me just mention a few words about the Black Hole Initiative that many of you heard about. We inaugurated the Black Hole Initiative about 1.5 years ago. And by now, we have operated for 1.5 years. We have 1.5 more years of funding, and we hope that it will continue for much longer than that because we haven't solved the information paradox as of yet, and many other problems in black hole physics. Before I get to describe the Black Hole Initiative, I just wanted to mention a few things for the speakers in this conference. First of all talks are video recorded. You can see the video equipment behind you. And therefore, they will eventually be posted on the conference website. So anything you say will be recorded. So make sure that you don't say anything that you will regret later. For example, we had a previous conference where Ray Weiss started telling us about what LIGO found, and then one of the LIGO members from the audience shouted, "But you're not supposed to say that." So we will hear more from Ray at the banquet tonight. So you should ask him embarrassing questions. There are also press representatives in the audience. So again, you might find in tomorrow's newspaper. If you say anything unusual, provocative, it might appear. Please deliver your presentations to the conference organizers at the end of your session. We will also include the PowerPoint presentations on the conference website. And I wanted to mention by name the administrators. The lead administrator is Nina Zonnevel, standing over there, and that you may have seen as you entered. Also have Uma Mirani, who is outside. Mark Palmer, who is standing over there, and Barbara Elfman, who is standing right here. So the Black Hole Initiative is just next door, 20 Garden Street. It's a Greek-looking building, as you can see in the photo here. And you're welcome to visit it throughout the conference in the breaks or anytime later. You're most welcome to be our guests in the future. This is a photo from the inauguration. Stephen Hawking made it across the Atlantic, especially for this event, after not traveling for 3 years to the US. He thought that it's an excellent idea to have a center dedicated to the study of black holes, since there are so many problems that are unsolved. Robert Dijkstra, the director of the Institute for Advanced Study at Princeton, decided to paint a mural that he dedicated to the BHI, and we hang in the corridor. If you go to the building, you will see it. It includes a binary black hole system and a bottle that represents the information paradox, and some strings that represent the view of some people about how quantum mechanics and gravity is unifying. And this is a group photo from the Black Hole Initiative that was taken early on. By now we have, for example, last year we got 6 new postdocs in addition to the 3 initial research associates of the Black Hole Initiative that we had, Paul Chesler, Andrea Poom, and Eric Curiel. And those that we got last year were Feraz Azar in philosophy, and you'll see all of these people in the audience. Maciek Wilgas in astrophysics, Mislav Balokovic working on the Event Horizon Telescope, which is an attempt to image the black hole at the center of the Milky Way galaxy. Laura Donay in physics, Xin-Yu Chen in gravitational wave astrophysics. She is a member of the LIGO collaboration. And Jordan Keller in mathematics. So as you can tell, this center combines expertise in at least 4 disciplines, astronomy, physics, mathematics, and philosophy, which makes it very interesting. You have people from different cultures speak to each other. At first, I worried that it may be like a Temple of Babel, where people speak different languages and cannot really work together, but it turned out to be quite productive. In fact, we learned the language of each other, and that enriches the intellectual atmosphere at the place. So it works extremely well, and I personally am thrilled to be in that place because of the many collaborations that it fosters. And we usually have weekly events and a colloquium, and you are invited to visit us in the future. So in terms of the senior people, the principal investigators, Shep Doleman is leading observational astronomy. He is the director of the Event Horizon Telescope. Peter Gallison is in the history of science and philosophy part. And you will see a short segment from a film that he is preparing on black holes later tonight. Ramesh Narayan in theoretical astrophysics, studying the inflow of gas towards black holes and the observational implications of that. Andy Strominger working on the physics of black holes. And S.T. Yao on the mathematics of black holes. And there is no need to introduce myself. I just wanted to mention that there are major aspects of black hole physics that are not well understood, and as far as I'm concerned, I was reminded of one of them when we had a flood in our basement just a week ago at my home. It led me to realize that actually the drain leads to a sewer line, okay, and it was clogged, and that's why we had this flood. And if you think about the black hole singularities, we all believe that matter goes down the drain and reaches the singularity. The interesting question is what happens to it there, and that's an unsolved problem. We don't have a good idea of what happens to a proton as it falls all the way to the center. And it's a major issue as to where the information actually goes, because the information is carried with particles. And so until we understand the singularity, we will not be able to figure out the full physics of black holes. So it's not the fact that they are hidden behind an event horizon clearly is not sufficient for us to shy away from the challenge of figuring out what happens at the singularity, because it's quite possible that once we realize that, there will be observational implications to any solution we find for the singularity problem, which is just in general relativity, the place where Einstein's equations break down. So we clearly need a different theory. And so with this major unknown, there is a lot to explore, and potentially the information paradox is linked to that as well. So I would like to ask Shep Doleman to open the first session. And I should mention that in all sessions we have a mix of people from the different disciplines, because we found it to be much more productive to have those mixes. And I invite everyone tonight to come to the banquet. It should be a wonderful celebration of the Nobel Prize in Physics this year and beyond.